150 years is the limit of a human lifespan. In theory, by this age, our body shuts down the ability to recover from injury, disease, and stress, which leads to death. This proves once again that every creature on the planet has a certain strength limit, except for fish, because fish don't need a body to survive. Actually, being a fish is quite challenging. Just imagine you live in a world where everything, and I mean it, absolutely everything, wants to eat you. Birds, mammals, humans, other fish, even insects. But it seems like fish got used to this. Steve, where's your back? My back? Did I have one? There are cases when the fish lost a bigger part of its body and survived. Well, not in the wild, though. For example, a fish rescued from a Thai market survived 6 months without half its body and tail. Apparently, it tried to escape from the artificial pond, but broke its tail when it fell. As a result, half of its body, along with the tail, simply rotted away. But the fish didn't die. Moreover, the person who bought it in the market took it around villages so that as many people as possible could see the strange exhibit. Unfortunately, in the end, the fish still died. Although I didn't find a reason why. Perhaps it tried to make another escape attempt and overestimated its strength. But can you really live without half of your body when you're a fish? I mean, I thought a wild nature is quite merciless, and fish like that instantly become someone's prey. Also, the wound can get infected. Hold on, maybe it's all about saltwater. Let's assume that most often the resilient halves of fish are found in the seas and oceans. Is saltwater good for healing wounds? Unfortunately, so far, scientists have not carried out specific experiments on fish. Things get confusing when it comes to humans, too. Saltwater, for example, saline, has long been used to heal wounds, in particular to cleanse foreign bodies out of the wound or before dressing it. At the same time, the water in the ocean is so far from being sterile. In theory, it can help heal wounds, but it can also carry infection into them, which will only make things worse. This means that seawater's not the answer. So why do sea creatures actually live so long and ignore injuries? And when I say long, I mean a very old age. You've probably heard about the Greenland shark, which can live for 500 years and reaches sexual maturity only at 150 years old. Meanwhile, I didn't find any information about long-lived giraffes. Okay, the sea and the giraffes are out of the equation. It's about the fish themselves. Evolution made them champions of regeneration, but only among vertebrates. Jellyfish can also regenerate quickly and literally reassemble themselves piece by piece. But these skills of the fish are still amazing. Regrow the fin? It's easy, but you won't surprise anyone with that. Scales? Come on. People also know how to heal wounds. What about the retina, spinal cord, pancreas, hearts? Some fish can regenerate vital internal organs. Hardly any vertebrate comes even close to these results, except for Deadpool. And Wolverine, of course. But they're mutants, so they don't count. Oh, I did have a back. But in nature, nothing appears without a reason. And since fish have acquired amazing regeneration skills, there must be some reason for that. As it often happens with exciting questions, scientists do not have a clear answer, but there are theories. Apparently, in the early stages of evolution, environmental conditions were very aggressive. In short, the likelihood of dying was very high. New species were struggling for food and a place in the sun, so they needed to survive somehow. If our very, very distant ancestors did not find a solution, there would simply be no life on Earth. And regeneration turned out to be a great solution. You can reproduce if you learn to regrow the necessary organs your neighbor just bit off. Well, to find evidence in favor of this theory, we need to look in the past. The good news is that we don't need a time machine. We just need to catch the right fish. Gars are an order of ray-finned fish that can even regenerate bones in their fins. At the same time, they're considered dinosaurs in the world of fish because they changed very slowly throughout their evolution and retained many features of their distant ancestors. In short, that's just what you need to study the history of regeneration. But the most interesting thing is that the Gar's genome is very similar to the human genome. In fact, there's something like a bridge species between ancient creatures and us. Research shows humans also have the genes responsible for regeneration in fish. We have everything we need, except for one detail. It's like a broken kettle. Imagine that you have great tea, water, a cup, cookies, and a cool electric kettle, where they forgot to put the power button. Humans lack the genetic mechanism to activate these genes. The switches appear to have been lost or changed during the evolution of mammals, which includes humans. Although it looks pretty weird, regeneration is a really cool feature that helps survival, and that's what every creature on the planet yearns for: survive and procreate. So why is our ability to regenerate reduced so much over time? Doesn't this contradict everything we know about nature? Well, the thing is, regeneration is a bit lazy. If you compare a fish and a tiger, it's clear who is more complex in terms of body structure. What about a bird and a frog? The bird is definitely more complex. The more complex the organism, the more resources and time it needs for regeneration. This makes no sense when you can easily and quickly patch up the affected area. This is how our wounds heal, but you'll never persuade your body to regrow, say, a finger? By the way, for the same reason, regeneration does not work for very small creatures like butterflies. Why waste time and effort on rebuilding the leg if you have 2 more days to live? What do you mean, why? I have another theory. Maybe too powerful regeneration would just prevent us from evolving. It's like a computer game. When you have the option to save, you don't have to worry too much about what you do. In any case, you'll start from the save point with the same conditions. But when you can't save, you begin to assess your every decision, ponder a lot, and try to guess what happens next. You have no right for a mistake. So the lack of powerful regeneration could well make our brain evolve and look for other ways of survival. Sounds pretty logical, don't you think? But if regeneration only slows down evolution, then it must be bad for the development. Does this mean cold-blooded creatures are less lucky than warm-blooded ones? Actually, this is a rather difficult question. On the one hand, cold-blooded animals need a constant supply of heat, while warm-blooded ones cope on their own. Imagine that your smartphone is charging by itself. Warm-blooded animals can live everywhere. They know how to raise their body temperature to kill microbes. Cold-blooded animals have to look for a source of heat, and this also takes more time than regular recharging. And when you stay in one place for a long time, it makes you an easy target for predators. In short, only cons. However, warm-blooded animals have problems too. They constantly lose energy, and the bigger the animal, the more food it needs to restore it and essentially survive. Take, for example, pandas. They have to spend from 10 to 16 hours a day on feeding alone. No wonder they've been endangered for a long time. Meanwhile, cold-blooded animals require much less food to survive. If you're already wondering whether it's better to be warm-blooded or cold-blooded, I have no answer to this question. Moreover, I don't think that nature can answer it as well. But evolution knows exactly what it's doing. Perhaps in a couple million years, it'll create a universal organism without any flaws. But for now, here's a fact for you. Even dead fish can regenerate. Not itself, though. It'd seem people and fish are too different. But as I said, our genome is similar, and the skin of a fish is surprisingly good for healing human wounds. In addition, it has anti-inflammatory, antimicrobial, antiviral, hypoallergenic, and analgesic effects. Yes, we're still talking about fish. The fish skin makes healing much faster. Moreover, it's cheaper and needs less processing. There are only 2 serious downsides. So far, the fish skin hasn't gotten a widespread application, well, and the fish usually protest. See you later.